Good morning. My name is Mweneni, and I'll take you through the Natural Science and Health 5. Our outline for the presentation, we start with an introduction, but we'll spend more time on metric conversions, which is converting units. We have picked up that during the examinations and assignments, there is always a problem with units, especially converting units. Then we will look at speed, acceleration, and spend some time on forces. These are some of the topics that are always part of the examination, but most of the time the calculations are not always well done. And then we'll conclude with looking at answering examination questions. This module, Natural Science and Health 5, is basically based on the physics, which is, we can define it as a study of matter and energy and the interactions between the two through forces and motions. So the unit have this module have 9 units that are mostly talking about matter, energy, forces, motions, and their interactions among these components. There is no prescribed textbook for this, and I advise you to take any grade 12 physical science book, any grade 12 physical science question papers or exam question papers. They will help you very much in answering the questions and passing this subject. And as I said, this presentation will look at the main issues in answering exam questions, and I'll give you some examples, especially the units. So we look at, firstly, international systems of units. We call them SI units. They are based on the number 10, and most of the time we look at, if we are measuring distance, we measure it in meters. If we are measuring the mass, we use grams. And if we are measuring volume, we use liters or cubic centimeters. And then there is weight, which is a force. We use a unit of weight, which is Newton. And there are those that are thank you. And then we have converted units. For example, for density. Density doesn't have a straight unit like distance have meter, but for density, because you have density is given by mass divided by volume, so the unit of density is converted, so it will be gram per cubic centimeter, for example. So in order to make it easier for you to be able to remember these units, and to convert them easily, we use this mnemonic. We can say King Henry died unusually drinking chocolate milk. So if we look at these units, we have King Henry died unusually drinking chocolate milk. Now let's go back to how we can use this example. You can memorize this, and it will help you very much in not being able to forget the units ever. So here, let's say we start with U is a unit. It depends now, what are you measuring? Is it distance? So if it's distance, the unit for distance is meters. If it's a mass, the unit for mass is grams. If it's volume, then it could be liters. So let's start with meters. So if we have a unit which is meter, and you are given kilometers, this is kilometers. Now for you to be able to convert, you have to count. This is based on 10. This is 10 units that are here, another 10 units that are here, and another 10 units that are here. So for you to be able to convert from kilometer to meter, then you have to either multiply or divide by 1,000. So that's why we say in 1 kilometer is equal to 1,000 meters. Because from kilometer to meters, then you multiply by 1,000 because we have 10, 10, 10. The same way, if we are converting with, let's say we have 1,000 meters and we want to change it to kilometers, then you must divide. So from kilometer to meter, we are multiplying by 1,000. From meter to kilometer, we are, here we are dividing by 1,000, and here we are multiplying by 1,000. The same way, if you are going to smaller unit, like for centimeter, this is C is for centimeter. Then here you have 10, 10. So here is 100. So either you multiply or you divide by 100. That's how it will help you to convert the units. So sometimes you'll be given kilometer and they say convert this to meters, or give the answer in meters, or they give you in kilograms and they say give the answer in grams. So this table here, it will really help you to be able to remember, even if you are in the examination. So it says here divide by 10 if you are getting bigger, and you multiply by 10 if you are getting smaller. So from kilometer to meter, we are getting smaller. So we are multiplying. From grams to kilogram, we are getting bigger. So we are dividing. That's how you should use this example to be able to convert your units. Usually in examination, units you might know how to do the calculations very well, but they may lead to an error that might make you lose marks. So use this table, study it very well, and then you won't have any problem with converting units, be it whatever unit you are given. As I said, we will focus on the units because in almost every examination, you are converting units. You have to use units in your calculations, the formulas, the quantities that you are given. Another example here, you have units. You are given the 3 different units that we are using, which is length, we have volume, and we have mass. For length, we use meters, and if you are given kilometers or centimeters, you have to convert to meters. For volume, we have liters, but mostly in our calculations we use cubic centimeters. And then for mass, we have grams. And then we have prefixes, like the previous one. We have kilo, centi, milli, either milligram, millimeter, milliliter, or centigrams, centimeters. And here you have a hint on how to do the calculations. From millimeter to centimeter, from centimeter to millimeter, and from meter to kilometer. And this you can only be able to tell if you know this very well. If you know this, like from kilo, hectare, deca, deci, centi, and milli. That will help you on determining whether you multiply by 100, whether you multiply by 1,000, or you multiply by 10, or whether you divide if it's from bigger or to smaller, or from smaller to bigger. Okay, this is on the units. Now let's look at an example of converting units. I'm focusing most of the time on this because I know after this you might not have any problem with units, and when you do your calculations, units are something that can fetch you marks, very easy marks, if you just put the correct unit there. Even if the answer is wrong, you might get that mark. So for that reason, we are spending that time on the conversion of units. Plus, if you don't get the right units, even if you know the calculations, they might lead you to wrong answers, and then you end up losing marks. So let's look at these 2 examples. three examples of converting units that are on the slide. Let's look at the first one. We have 2 kilometers is equal to how many meters? So if you have to convert from 2 kilometers to meters, if we go back to our first slides, we said for King Henry, we look at the unit. The unit we have here is meters. The unit we have here is meters, and we want to change these meters and kilometers to meters. But now in between there is 10, 10, 10. Now to change this from kilometer to meter, we have kilometer to meters. We have here the unit is meter, and we are changing from kilometer to meter. Now in between here there is 10, 10, 10. So that means it's 1,000 in between. If we multiply 10 times 10 is 100 times 10 is 1,000. Now moving from kilometer to meter. Kilometer is bigger, meter is smaller. So when you are moving from bigger to smaller, you multiply. So when you are getting from bigger to smaller, what you are getting, the unit that you are getting is smaller, then you must multiply. That means in this case, from kilometer to meter, because the meters are smaller, we have to multiply. So 2 kilometers is equal to 2. Now this is kilometer, we have to multiply by 1,000 meters. Then that will give us our answer will be 2,000 meters. That's the first example. This is the answer. From bigger to smaller, we are multiplying. Now let's go to the next example, which is 300 meter. We want to change 300 meter, and we want to change it to centimeters. Still we are moving from, if we look at our first, we are moving from meters to centimeter. Meters are bigger than centimeters, but in between here there is 10 times 10, then is 100. So that means we are multiplying. This is 300, and we are multiplying by 100. Then it gives us 300 times 100. Then we have, it will be 30,000 centimeters. So that will be our answer, because when you are moving from big to small, you must multiply. Okay, now let's, 250 grams is equal to how many milligrams? This I think you can do, is the same as the other two examples. You are moving from big to small. Now let's look at the volume, the example of the volume that we are given there, which is in liters. So we are given 500 milliliters. The question is, how many liters are in 500 milliliters? How many liters are in 500 milliliters? Now this one we are moving from small to big. If we go to the first metric conversion, the slide that we're having there on units, we see that milliliters. Let's go back to our very first examples that we were having there for King Henry. I will keep referring to this so that it will help you remember. Now we have liters and we have milliliters. Milliliters, and we want to change it to liters. Now in between here there is 10, 10, 10. This will be 1,000. So now milli means is 1,000, so but we are moving from small to big. When you are getting bigger, you are dividing. So let's look at our example. Now we know where our units are coming from. We have 500 milliliters, and is how many liters? Now we have to divide because we are getting bigger. So now we have 500 and we divide by 1,000. Then it gives us how many liters? We get rid of the zeros. 5 divided by 10 is a half, so we get 0.5 liters. So that means 500 milliliter is equal to 0.5 liters. So that is our answer. Just take note, when you are converting from bigger to smaller, you are multiplying. When you are converting from smaller to bigger, you are dividing. Okay, now we go to the next topic, is speed. We look at speed, but we can't talk of speed without talking of distance and displacement. We are talking about the length or distance, which is measured in meters, which we were just converting now. The unit for length is mostly meters. Sometimes when you are doing calculation and it's longer distances, it's kilometers. But mostly if it's not stated, the distance is measured, the SI unit is meters. And then we look at the concept of displacement. What is displacement? Displacement is nothing other than a change in position. Here we have an example of how to figure out the speed. How to figure out the displacement. Let's say we have this person is running starting from a start and ran for 50 meters and came back again, but he didn't came back to the same position where he started. He ended 20 meters from the start. Now, what is his change in position? What is his displacement? His displacement is just 20 meters. 20 meters because from where he started to where he ended up, his change in position is just 20 meters. He started, let's say he started here. Okay, the papers are getting finished. Wait. Okay, let's say he starts from this. This is the runner. He started from this point. And he ran for 50 meters. And ran back again, but he didn't come to the same starting position. He ended up here. Let's say he ended up here. Now, from where he started to where he ended up, this is where he ended up now. Only 20 meters. So we say his displacement. His displacement is 20 meters because from where he started to where he ended up, that is 20 meters. We are not counting the whole total distance that he traveled, but we just look at where he started and where he ended. That's why we say displacement is just a change in position. But if we are asked, what is his displacement? Displacement is 20 meters. What is his total distance that he traveled? Total distance that he traveled is not the displacement, so we have to add 50 meters that he traveled and the 30 meters again that it traveled, then that will be 80 meters. Okay, then we go to the next concept. We usually calculate the average speed, but when we calculate the average speed, we are talking of a change in time. Thank you. We are talking of a change in time. The change in time, when we say something, there's a change in time, we say is a rate. We call it a rate. So now the rate of change in position, that refers to the time. Let's say if you think of distance as a change in position, then the speed is the rate at which the distance is traveled, or is a rate of change in position. That's what we call speed. And this is the formula that we use for calculating speed. So speed is given by the distance traveled divided by the time it takes to travel that distance. And sometimes we use S for distance instead of a D. And the unit, now if we look at this, because we were focusing on the unit, I really want us to, when you do your calculation, you have to be mindful of your units. Now we have distance, which is measured in the distance measured in meters. We have the time measured in seconds. So our unit will be meters per second. That is our unit for speed. Then when we talk about the average speed describes the speed of motion when the speed is changing. And we say, we usually use a triangle when we talk about the average speed, especially in our formulas in writing. We say we use a triangle. Let's say the average speed is the change, the total distance traveled divided by the change in time. That gives us the travel. Let's say maybe you started off with a certain speed, then you start moving very fast, then you start slowing down. You are not moving at a constant speed. Your speed keeps changing. So for that whole journey, we look at the average speed. And we use a triangle to denote that change. Let's say, for example, here we have an example. If the total distance traveled was 5 kilometers, now here we have the question. And this, when you are doing your calculations, especially in the examination, please show your work. Always show your work. And start with what is given. Let's look at this question. Let's look at this question. The example we are given here. What is given? First, we have to figure out what is given. We are given the distance is given there. They say is 5 kilometers. And the total time is 0.5 hours. Okay, 0.25 hours is a quarter of an hour. Now you are asked to calculate the average speed. We say the average speed is equal to change in the distance over the time taken. But the total distance that was traveled was 5 kilometers divided by the time, which is 0.25 hours, which is a quarter. Then it gives us a speed in kilometer per hour. You can calculate that. So this is the answer, which is 20 kilometers per hour. That is the average speed. There is the solution. I hope when you come to these worked examples, first try to work it out for yourself, then you can compare your answer with the solution that is given. Now, because we are talking about the average speed, we can't talk about the average speed without talking about the instantaneous speed. The instantaneous speed is the speed at a given point in time. suppose you are in a car moving. The car is always, the speedometer of the car is always reading the speed of the car, the speed that the car is traveling at. But that speed of the car is not the average speed. It just shows at that point in time the speed of the car. So this speedometer is showing the instantaneous speed. As soon as the car starts speeding, it shows how the speed is. As soon as the car is slowing down, it also slows down the speedometer. So that reading, it shows that speed at a point in time, which is what we call instantaneous speed. Now, the next one we are always asked to calculate in our examination will be either speed, velocity, or acceleration. Let's look at the velocity. Velocity describes how fast something is moving, but the difference between speed and velocity is velocity looks at the direction. Is in which direction? Is it going, is it coming, or is it heading south, east, west? That is the velocity we are talking about. But for speed, we are not bothered about the direction. We are only looking at the size, how fast, how slow. But for the velocity, it looks at how fast, how slow, in which direction also. Velocity considers the direction. So we say it have both size and direction, so it's a vector quantity. Speed is a scalar quantity because it only has size. So here it says velocity includes the speed of an object and the direction of its motion. Because velocity depends on direction as well as speed, the velocity of an object can change even if the speed of the object remains constant. A car moving at 20 kilometers per hour in a certain direction, it turns at 20 kilometers per hour and changing its direction. That means that car have already changed its velocity, but the speed remains the same. The calculations for speed and velocity is the same. They use the same formula. So for velocity is still given by the distance traveled divided by the time taken. It's the same as the speed, but only that for velocity we have to consider direction. Now let's look at acceleration. Acceleration is the rate of change of velocity. When the velocity of the object changes, the object is accelerating. It could be when it changes. It doesn't mean necessarily when we are talking about acceleration is always an increase or a positive change. Sometimes it's slowing down, it's still accelerating. A change in velocity can be either a change in how fast something is moving or a change in the direction it is moving. So you must always be mindful of the direction. As soon as the direction changes, even if the speed did not change, then the velocity changes. That means that the change in velocity is also a change in acceleration. When you think of acceleration, you probably think of something speeding up. We are saying the car is accelerating. It's moving very fast. But in physical science, accelerating could be a slowdown also. An object that is slowing down is also accelerating. Only it is a negative acceleration, not a positive one. Acceleration also has direction, just as velocity does. So both velocity and acceleration are vector quantity in that they have both magnitude and direction. This is how we calculate acceleration. And in many exam questions, you'll be asked to calculate acceleration. And we have to look at the change in velocity, the final velocity minus the initial velocity, which is the initial velocity. We are talking about the velocity at the beginning of that particular time. And This is an example, one example of using acceleration. We say acceleration is a change in velocity divided by a change in time, which is usually given by the final velocity minus the initial velocity. We use an I for initial and F for final to show that this is the final velocity, this is the initial velocity, and then we divide it by time. A change in time, it could be time at the end, which we call it T2, and minus the initial time at the beginning, which we call T1. Let's look for example. This example that is given here. Suppose a jet airliner starts at rest and at the end of a runway reaches a speed of 80 meters per second in 20 seconds. We have to be mindful of our units always. Okay, let's say we start first with what is given. What is given? What information do we know to be able to answer this question? We have a speed is given. Speed is given, which is 80 meters per second. We are given the time, which is 20 seconds. We know they say when it starts at rest. At rest means it was not moving. Therefore, we know the initial speed. Initial speed is 0. Initial time is 0 also. Because it was not moving. Then it starts from rest. Then we know our initial velocity is 0. Then we know this is our final velocity. Then let's calculate the acceleration. Is given by a change in speed or velocity divided by the change in time, which is given by final velocity or final speed minus the initial speed, and then we have the difference between the time the time at the end and the time at the beginning. But now we know for our acceleration, the final speed was 80 meters per second minus the initial was 0 meters per second. And then the difference in time also, at the end it was at 20 seconds minus the T1 is 0 seconds. So whenever you are doing calculations, you know when you are subtracting something minus 0, 80 minus 0, then we know it's just 80 meters per second. Then we divide that by 20 seconds, because 20 minus 0 is just 20. Now we have the 2. This is second, this is second. The unit for acceleration we know is this. We divide 20, then it's 4 meters per second square, because now here we have our two seconds and seconds, then it's second squared and meter per second squared. This is our unit for acceleration. Acceleration, the unit is meters per second squared. It's always help you when you put in your units in your calculation. It will help you to derive the correct units. And this is our solution here. Whenever you do your calculations, please try first to work it out. Then you can compare your solution with the given answer. As I said previously, just to highlight on the acceleration, positive acceleration, something that is speeding. Negative acceleration is a slowdown. And these two graphs are showing the two. When it's accelerating, increasing in speed, then it's positive, the gradient is positive. When it's slowing down, it's still acceleration, it's negative, then the gradient of the graph will be negative. Okay, the other thing that we'll look at is mass. Mass is a measure of inertia. We define mass as an amount of matter in an object. But I want to focus on what mass is not. Mass is not volume. Mass is not weight. Usually when you go on a scale, you weigh yourself and we say that is mass. And here we talk about inertia. Inertia is the resistance of an object to a change in its state of motion. I will give you an example of a moving car. If you are moving in a car, you are sitting in a car, the car is traveling at a certain speed, let's say 20 kilometers per hour. No, let's make that bigger. Let's say 120 kilometers per hour. This car is moving very fast. You are sitting there, relaxing. All of a sudden, the car hits, the driver hits the brake. You will still be moving forward when the car has stopped. That is your inertia, that resistance to the change. You might even end up bumping either with the windscreen or somewhere, or trying to lean on something in order to stop that movement. The body is still resisting that change in the state of motion. That is what we call inertia. Then we look at other forces, which is friction. The friction is a force that resists the motion of objects or surfaces. In between the surface between the two objects, there is always a force in between that is resisting that change. Friction always works in the direction opposite from the direction the object is moving, or the direction that the object is trying to move. Friction usually slows down a moving object. We have many different frictions. You need to go back to and study more on friction. This is just to highlight on some of these forces. And on this, we look at the calculations involving force, mass, and acceleration. We look at the forces, we looked at the mass, we looked at acceleration. Now let's look at the Newton's law of motion. Inertia we have already talked about. The first law of motion, which is inertia, it says the object will keep on moving, like you're in the car, sitting in the car is moving. As soon as it hits the brake, your body still wants to keep moving, so you end up hitting something, either the windscreen if you're sitting in the front. So that is what Newton's first law of motion is saying. It says the object will keep on moving unless an unbalance or something else act on it to stop that. If something is resting, it will keep resting unless another force acts on it. Now we go to the Newton's second law of motion, which involves force, mass, and acceleration. This Newton's second law of motion, it describes how the force exerted on an object, its mass, and its acceleration are related. And this we use it for, this is a formula we use for calculation. To calculate the acceleration that involves the second law of motion, we use this formula here, which is given by Newton's second law of motion, which says force is equal to mass times the acceleration. Let me write it out. Force is equal to mass times the acceleration. Because of time, I'm not going to go through the calculation for this force, mass, and acceleration. We go to the next concept, which is air resistance. Air resistance is also one of the concepts that are misunderstood. We say air resistance is the amount of air resistance on an object depends on the speed, the size, and shape of the object. Air resistance, not the object's mass, is why feathers, leaves, and pieces of paper fall more slowly than pennies and other heavy objects. If you have a feather or a piece of paper and you have an apple and you drop the two, like shown in the example, and you drop the two at the same time, the piece of paper will float in the air, but the apple will just drop down straight to the ground. It will fall faster than the piece of paper. It's because of air resistance that creates that force, the net force and the gravity, but the net force acting on it, because of the air resistance, it will be much lower, and then the apple will fall much faster. And then this brings us to a concept of gravity. What is gravity? Gravity is an attractive force between any two objects that depend on the masses of the object and the distance between them. So between the objects, as long as that object have mass, it have gravity. Only that for some, we can't feel its effect as much as the gravity, the gravitational force of the earth. Because the earth is bigger, then we can feel its effect. Other objects like a cup or even us, our mass is negligible, so that gravity, that force between the two the objects, it cannot be felt because it's smaller. Okay, now we come to weight. Weight is a gravitational force exerted on the object, and this usually is depending on the Earth's gravity, is equal to the force of the Earth's gravity on the object. And here I want us to look at the calculation of the weight. Weight, which is a force. I'm writing it next to our Newton's second law of motion. Weight is a force, is given by mass times gravity. Acceleration, this is now acceleration due to gravity, which we say is a G. And most of the time when you must, in your examination, this is a constant, it's always 10. Gravity is always 10 meters per second squared if it's acceleration, or if it's we say is a force, then it's a 10 Newton per kilogram. That's the Earth's pull. Or we can use it as meters per second squared if we are referring to gravitational acceleration. But it's always a constant, which is 10. So if you are given to calculate the weight, don't expect to say, if the question is saying calculate the weight of 2 kilograms to be given a gravity, then you must already know that gravity is always 10. Depending on what you are referring to, if you are referring as a force, then it's 10 Newton per kilogram, that's the Earth's pull, or if it's a gravitational acceleration, then it's 10 meters per second squared. Then we look at the difference between mass and weight. It's also one of the common questions. Describe a difference between weight and mass. Weight and mass are not the same. Weight is a force, while mass is the amount of matter in an object. How many atoms or how many units are in that matter, in that object, that is a measure of its mass. Weight and mass are related because weight depends on the mass. Weight increases as mass increases. And this brings us to the end of our presentation for today, but I want you to remember some of these equations for your examination. The force and motion equation, we have the equation for average speed and for the average velocity, which are the same, given by the total distance divided by the total time. We have the formulas for calculating acceleration, and then we have other formulas for linear motion. Though we didn't go into linear motions today, they will still come in the examination, in the assignment. You come across them, and these are some of the equations that you need to know. We didn't get to go to the electricity part, but these are some of the equations that you need to know. Ohm's law is especially important, so you need to know it on how to calculate the resistance, the current, the voltage, as well as the power. You need to know how to calculate the resistance and the current, as well as the voltage, both in series and in parallel connections. And as I said before, don't expect to be given. Sometimes it's not going to be stated that what gravity or its value is, but you should know, and you should know that gravity is equal to 10 Newton per kilogram, or if we are talking about the acceleration, gravitational acceleration, then it's 10 meters per second squared. You need to know the charge for the electronic mass. You need to know the speed of light. Sometimes, especially with wave equations, you need to know the speed of light. Energy mass equation, you need to know the speed of light is a constant, so it's 3 times 10 to the power 8 meters per second. That you also not be given, but within that equation, this equation, let me write it here, the mass energy equation. The mass might be given, we have E is equal to mc squared, but here you know the speed of light is always 3 times 10 to the power 8 meters per second. So these are some of the constants you need to know. These are some of the constants you need to know, especially gravity, especially the speed of light. Okay, now some hints on answering the examination questions. Marks will be awarded when you are writing. Be mindful of this. Marks are awarded for the correct formula, the correct substitution, like I have been showing you, the correct answer with units. No marks will be awarded for incorrect or inappropriate formula used. So if you have used the wrong formula, unfortunately, you will not be awarded any mark for that. Even though maybe you have used relevant symbols and substitutions, you have substituted correctly into the wrong formula, then you will not be able to be awarded any mark. When an error is made during substitution into a correct formula, let's say for example you have an equation like this, but in substituting for mass you have written something, force is equal to mass times acceleration, that's your correct formula, but when it comes to substitution, you either put in a wrong mass or a wrong acceleration. The mark, you will just get the mark for the formula, but other marks, because obviously even the calculation, even the answer, the final answer will be wrong. You only get the answer, the mark for the correct formula, but for the other things, the marks will not be given. So it's very important for you to be able to start with a formula always. Always show your work, start with a formula. You might get that mark for the formula. If for some reason you have made a mistake, then that mark will be forfeited, but you still get the correct answer, the one mark for the correct formula, and you might even get a mark for the unit if the units are correct. Then instead of losing all the 3 marks, you can get 2 marks, and then just lose the marks for the substitution and the calculations that are wrong. If no formula is given, and this is very important, I have to stress, if no formula is given, but all substitutions are correct, you will lose a mark for the formula. So always start with your calculations with the formula, what is given, you write the formula, substituting, don't forget the units. You will end up getting if the answer is not correct, the final answer is not correct, you will get at least get the marks for the correct formula and for the correct units. Good luck with your examination. That is the end of our presentation.